Hello student, I am Odison Alekwandiola, your favorite chemistry teacher, and in today's class we are going to be looking at deriving equations for electrolysis questions. I have found out that in most cases, most students have problems with solving electrolysis questions based on the fact that the way we have been taught to solve the questions. So I'll be teaching you how you can derive equations for some of these questions and some of the formulas you can use to solve them in a quick and more effective way. Now, you recall that electrolysis is defined as the chemical decomposition of a substance in molten or aqueous state when electric current passes through them. And of course, you also recall that we have two laws of electrolysis as coined by Faraday. Number one is the Faraday first law of electrolysis, which states that the mass of a substance deposited during electrolysis is directly proportional to the quantity of electricity passing through it. That is, M is directly proportional to Q. Then, of course, we need to find constant of proportionality. That is, M is equal to ZQ. Let's call this one equation 1, where M is the mass, Z is called the electrochemical equivalence, and Q is the quantity of electricity. However, we also know that Q is equal to, that's quantity of electricity, is equal to current times time. Current times time, that is I times T. Therefore, Q is equal to IT. Q is equal to IT. When we slot this in equation 1, we can say M, therefore, is equal to ZIT. Let's call this one equation 2. Let's call this one equation 2. Again, we can move ahead by saying that we go to the second law of electrolysis. The second law of electrolysis. Now we have been able to derive two equations for the first law of electrolysis. Now the second law of electrolysis says that when the same quantity of electricity pass through different electrolytes, the number of moles is inversely proportional to the charge on the ion of the element. That means number of moles is inversely proportional to charge. Then now we can say that this charge is equal to N, number of electrons, multiplied by Faraday's constant. Therefore, we can say N is equal to, now to find a constant of proportionality, after getting this, to find a constant of proportionality, we can say N is equal to Q over E. Then, therefore, since E is equal to NF, that's number of electrons times Faraday's constant, we can say that N is equal to Q over NF. Let's call this one equation 3. So when you are given number of moles, you are given the quantity, or you are given the Faraday's constant, and then they ask you to find Q, you can find it easily. Now, by getting this from this equation 3 now, from this equation 3, we can begin to derive so many equations. From this equation 3, we can begin to derive so many equations. We can say since N is equal to Q over NF, recall that number of moles is equal to mass over molar mass. Mass over molar mass. Therefore, if you substitute mass over molar mass to this, we can get mass over molar mass is equal to Q over NF. Let's call this one equation 4. Mass over molar mass is equal to Q over NF. Then we can say that since Q is equal to IT, then mass over molar mass is equal to IT over NF. Let's call this one equation 5. That means that if you are given current, time, and probably they ask you to find mass, you have the molar mass, you can find any of the given variables here. Okay, so that is that. We can also say number of moles is equal to the volume of a gas in dm cube over molar volume at STP. For a gas at STP, this is the formula for the number of moles. Therefore, we can say that in putting it here, we can say volume. Let me represent the volume with V. We can say V, molar volume of a gas at STP is 22.4 dm cube. So you can say V over 22.4 dm cube is equal to Q over NF. Is equal to Q over NF. So this is equation 6. Then since Q again is equal to IT, we can therefore say V is equal to 22.4. V over 22.4 is equal to IT over NF. Let's call this one equation 7. Call this equation 7. Again, we are just toying with the formula for number of moles. Again, we can say that N is equal to CV. That's concentration in mole per dm cube times what? Volume. N is equal to CV. Then in putting that in that formula, we can also go back and say that CV therefore is equal to Q over NF. CV is equal to Q over NF. Since number of moles is equal to Q over NF. Then since Q is equal to IT, you can say, call this one equation 8. You can say CV is equal to Q is equal to IT over NF. CV is equal to IT over NF. Call this one equation 9. Call it equation 9. Again, like I've told you, we are toying with the formula for number of moles. We are toying with the formula for number of moles. Again, you will also recall that the number of moles N is equal to the number of atom, or the number of particle, or the number of molecules, or the number of electron over Avogadro's constant. You can recall over Avogadro's constant. Therefore, we can now say, since Avogadro's constant is 6.02 times 10 to the power 23, we can say that substituting it here now, we can say Na, MP or MP or Nm or Ne over 6.02 times 10 to the power 23 is equal to Q over NF. Is equal to Q over NF. That means you can be given, they can ask us to find the number of atoms, or number of particles, or number of molecules, or number of electrons. Then we can say 6 over 6.02 times 10 to the power 23, which is Avogadro's constant, is equal to Q over NF. Then of course we also know, call this one equation 10. We also know that Q is equal to IT. Then we can say Na over or MP or Nm or Ne over 6.02 times 10 to the power 23 is equal to IT over NF. Call this one equation 11. So sometimes you might be asked to find the number of atom, and they give you current and time, and the far this concept is equal to 96500 column. Then they ask you to find this, so you can slot in the value straight to get that. Okay, so you can solve it in any of these ways. Again, we can also say that since mass is equal to ZQ, that's electrochemical equivalence, and is directly proportional to E, we can say mass of X over mass of Y is equal to ECE, which is the electrochemical equivalence Z of X over ECE of Y. Call this one equation 12. Call it equation 12. With these equations, you can solve as many chemistry questions, electrolysis questions as possible. For those that are doing exams that require speed, you just slot in the value as given and then you solve. My homework for tonight, for this class, is look for electrolysis question and use any of these formula based on the parameters given and solve. In the next class, we are going to be looking at different questions that has to do with this. Have a lovely day. I hope you enjoyed this class. Let me see you in the comment section.